Okay, welcome back to another example of proving complex conjugates. So in this one, we want to prove that Z1 times Z2, its conjugate, equals the conjugate of Z1 times conjugate Z2. So just basically separating the conjugate. Remember what we did in the other example with that Z1 equal X1 plus I Y1, and we let Z2 equal X2 plus I Y2. So the left-hand side, so we're going to follow this and we're going to prove it equals this. The left-hand side equals x plus iy1, x1 plus iy1. That's being multiplied by x2 plus iy2, all being put to the conjugate. Okay? That equals, if we expand this, we get x1, x2 plus x1 iy2 plus iy1 x2 plus I squared y1 y2, all having a bar above it. This actually simplifies down to, okay, the I squared becomes a negative, okay, and I'm going to group my imaginary parts and my real parts because this becomes a -1. So this becomes a real part, and I'm going to group it with the x1, x2. So x1, x2 minus y1, y2, that's from here. Plus, I'm going to factor the I out, okay, x1, y2 plus x2, y1, all having a bar above it. Now, this is just a complex number, okay? If we find the conjugate of this complex number, it actually just turns into a minus. Okay, now this does in fact equal the conjugate of Z1 times the conjugate of Z2, this part here, and which equals the right hand side. And you can prove that if you go and prove the right hand side. If I take this side, the conjugate of Z1, which is x1 minus iy1, and I multiply it with x2 minus iy2, you will in fact get this. Okay? So that means that equals that, so this equals that, and that equals the right-hand side. So you've proven this complex conjugate rule. Okay? Next video I'm going to look at is division.